Calculators. This is very important that you do. We need to get these calculators into degree mode. Okay. So my TI stuff doesn't really work, but are you okay?
Yeah.
What happened?
I just got like, she's not startled. No, I just, you know, chill.
You gotta chill?
I'm gonna.
Did the calculator shock you in some way?
No.
Are you sure?
Yeah.
Okay. All right, so I'm gonna bring up a picture of the TI calculator. That's what we're gonna talk about. I just need an image. All right. So here is your calculator. All right. It doesn't work on my calculator on my computer for some reason. I've tried it so many times. I've uninstalled it. I've reinstalled it. I got to talk to tech about it.
Can you use the new one?
The new one. I don't. It's the same one. Same keys. Okay. What I want you guys to hit the mode feature. Mode. Now you're gonna see a line that says radian degree. Scroll to degree.
Wait.
What was the first step?
No. Okay, it's clear, bro. Oh,
Go down to radian and then go.
All right, scroll down to degree. Hit enter to make sure that it kind of fills the background, right? I think it changes to like a black background, right? Okay. And then that changes your calculator to degree mode. There's two modes in your calculator. There's radian and there's degrees.
What does that mean? What did I do?
Degree is what we've been using, right? Degree measures. Radian is dealing in terms of pi and involves the unit circle. You're going to learn a lot more about that next year.
Wait, but I've been using radian now.
That's okay, but you just can't use it for this part. Okay? If your calculator is not in degree mode for this part, you are going to get the wrong answer every time. So you have to make sure your calculator is in degree mode. So here's my next question. How many of you share your calculator with a friend or a sibling or something like that?
Well, maybe next year.
Next year, you're going to have to swap back and forth. I'm not going to lie to you. Okay?
Oh, wait, my brother. Oh, shoot, I gotta go.
Okay? If you do, when you get your calculator back from whatever person you loaned it to, make sure you put it back in degree mode, because if they're in another class, like pre-calc, it's going into radian mode. Okay? There is no default. The default's radian. Yeah, the default's radian. So degree mode you have to physically put in. But once you do it, it's in there. So if you just keep your calculator yourself, as long as no weird buttons get pushed, you should be fine.
Wait, what's the difference? Like if I don't switch it back to radian, what do I lose?
If you don't switch it back to radian,
Yeah.
you're fine for this. Yeah, you're fine.
Like my calculator can be a calculator.
Yeah, it's still a calculator, but when we talk about right triangle trig, if you're in radian mode, it's a completely different story. So just trust me, it's different. Okay. So just to recap here, remember, degree mode. You are going to click the mode button. You're going to scroll to degree and then hit enter. Okay, so that's how you get to degree mode in your calculator, and keep it in degree mode. If you did this correctly, you should see like a DEG somewhere on your home screen. DEG. It'll be like kind of up in the corner or something like that, maybe a lower half.
Mine says normal, flow, auto, real, degree, MP.
Yeah, degree. That's what we're looking for.
Oh.
Yeah. If you are in radian mode, it'll say RAD for radian. So that's how you know what mode you're in. All right, let's talk about this now. So parts of a right triangle. Now, I know we've already gone over this, but we need to talk it in terms of specific angles. So here is what you need to do. And this is, again, very important. Whatever angle is in question determines what types of parts you have. Okay? In this case, this line right here is going to be known as the adjacent leg. This is still your right angle right here. Now, this is going to be considered your opposite leg across from the acute angle in question. So this is your opposite leg. And again, directly across from the right angle, we have the hypotenuse. So the hypotenuse hasn't changed. Technically, the legs have not changed either, but we have to determine them based off of adjacents and opposites. All right, so it says, given an acute angle of a right triangle, identify the opposite leg and the adjacent leg. All right, so given the acute angle of a right triangle, identify the opposite leg and the adjacent leg. So what we need to do is we need to determine what's what. So we're going to use this triangle to find the following. So the two acute angles we have are R and Q. They're asking us for the opposite of Q. So I'm going to circle Q, and I'm going to draw a line straight across. That opposite of Q is RS, making the adjacent SQ. For angle R, again, I'm going to circle angle R. The opposite is going to be SQ. And the adjacent will be RS. Now, the hypotenuse will never change even based off the angles. That will still be RQ. Anybody still writing? All right, so the ratio of the lengths of two sides of a right triangle is a trigonometric ratio. Trigonometric ratio. Trigonometry. You know how we have geometry, which is the mathematics of shapes? Trigonometry is the mathematics of triangles. Huh? Yeah, geometry, but trigonometry is just specifically triangles. I'm sorry? I haven't checked, but I don't think so because you guys are going to be dealing with more complicated stuff anyway, so I think we're okay. All right, your three basic ratios are sine, cosine, and tangent. You will not be calling them sin, cos, and tan. It is sine, cosine, tangent. And when I say sine, I am not asking you about what star sign you are. I am asking you about a specific angle of a triangle. Cosine does not mean, oh my gosh, Leo and Sagittarius, we totally get together well. All right? And a tangent is not a man who sat out in the sun too long. All right? But here are the abbreviations. We have SIN, COS, and TAN. Those are the abbreviations for these, and we're going to find those in the calculator. If you guys look, you guys should have in your calculator a sine, cosine, and tangent button. Please identify them now. Oh, no. That's just an abbreviation. We do not call them sin, cos, and tan. It is sine, cosine, tangent. Believe me, that'll be very helpful for you guys next year. Okay? All right. Guys, literally, if you come up to me and say, hey, I don't understand what the sin is, I'm going to be like, I think you should pray more or something. I don't know. All right? It is sine. Sine, cosine, tangent. I don't know what to tell you. You have to say those words, okay? Huh? What? Next year, because you're going to get 3 other trig ratios? Yes, very similar. So it's easier to just say the word. All right, so in this case, we have SOHCAHTOA. SOHCAHTOA. SOHCAHTOA in the water. Anyway, this is an acronym that will help you remember what goes with what. So for sine, we have opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you know how to spell this, you have what you need. Otherwise, you can memorize. In this case, the sine of an angle is going to be the opposite leg over the hypotenuse. The cosine is going to be the adjacent leg over the hypotenuse. And the tangent leg, or the tangent angle, is going to be the opposite leg over the adjacent leg. So it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Questions? All right, let's talk about these. Find the sine, cosine, and tangent for each angle indicated. So we're looking at M, guys, and we're looking at N. Here is M. My opposite is going to be 40. My adjacent is going to be 9. So if we're looking for the sine of M, that's opposite over the hypotenuse. So that'll be 40 over 41. Cosine of M. Here is the angle. We're using the adjacent 9 over the hypotenuse 41. Yes. We're not going to do it. Well, that's just a fraction, but we're going to get into that in just a minute. We're not doing that right this minute. All right. So this is going to be 9 over 40. Oh, sorry, 41. Sorry, 41. And the tangent is going to be the opposite over the adjacent, which is going to be 40 over 9. I want you guys to do it for angle N. So here's angle N. Now it flip-flops. There's your opposite. This is your adjacent. I'm going to give you a minute. Go ahead. Do the sine, cosine, and tangent of N.
I don't even gotta look at the screen. I can remember it now.
I don't even need my secretary.
All I need is my brain.
Aiden, you got these 3?
Yeah.
Tell me what they are.
Okay, so the sine
Good.
is 9 over 41.
Okay.
Okay.
Next.
Cosine is 40 over 41.
Very good.
And the tangent is 9 over 40.
Very good. Questions on this? All right, let's take a look at example 2. So this says find the sine, guys, sine of r, cosine of r, and tangent of r. Express answers as a reduced fraction. So looking at this, we don't have everything we need because we are missing SR. How am I going to find SR first? Pythagorean theorem. So here I'm going to have 14 squared plus 48 squared equals SR squared. Someone tell me, what does SR equal?
$50.
50, thank you.
I got it. I'm so smart.
Okay, so now that we know that we are finding just R, here is the angle in question. Here is our opposite. This is our adjacent. So I want to see, someone tell me, what is the sine of R, the cosine of R, and the tangent of R? Hold on, someone's saying it. Shh. Say it loud, say it proud. Yeah.
Is the 50 after each square root?
Yes. All right, someone was saying it.
I got it.
You gotta give it to me, Patrick.
The sine is 14 over 50.
Okay, what does that reduce to?
Oh
my god.
7 over 20.
7 over 25. Cosine, what do we got?
That's a decimal. 24 over 25.
Yeah, 24 over 25. And the tangent?
7 over 20.
Perfect.
Boom, chocolate.
Questions on that? Okay, again, take out those calculators. This is all calculator based right now. So looking at this next one, it says, when solving problems using trigonometric ratios, make sure that your calculator is in degree mode. We already did that, so you should be good. All you need to do here is evaluate these, and it says round, in this case, to 3 decimal places. I'm going to tell you right now, directions are going to be super important now. If you guys don't read the directions and you round incorrectly, you are going to get the problem completely wrong. Okay? If it says 3, if it says 2, if it says hundredths, it says thousandths, it says tenths, you have to be careful. Okay? So take out your calculators, and I want you to hit the sign button and then type in 52 and close the parentheses. Someone tell me, what does that equal? Very good. All right, now I want you guys to do the rest. Go ahead.
So easy.
It's a 0.754. So why is this like the funniest word? Fun?
It's not a word, actually.
The most funny.
Not really.
The most funnier speaker. 45-81.
Show of hands who's still finding these 3. Okay, give me another minute. Then we're going to do a big reveal. Big reveal. What? Dinner reveal? Is that what you just said?
Oh, 10 45 is just I know. That's why I know.
All right. Dun, da, 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 da.
Wait, did you say?
These are the numbers you should add. 0.788, 0.754, 1, and 0.292. Okay. Now, here are the steps for using trig to help find the lengths of missing sides of a triangle. Pythagorean theorem only goes so far. If you're only given an angle and one side, you need to find the other side using trigonometry. Okay? So, write down these steps. Step 1, choose one of the acute angles in your triangle. 2, label sides as opposite, adjacent, or hypotenuse. 3, write your trig equation. And 4, solve for your side.
gave you popular and you knows.
Wait, throw out.
It's like barely. It's at first.
So easy.
Watch tomorrow.
Tomorrow, why are you going to school on Saturday?
Okay. Tuesday.
Why are you going to school?
The cute one.
You know, speaking of school on Saturday, my husband says some people are like school on Saturday. No class.
Oh, I get it. I get it. Yeah.
Some people are like school on Saturday. No class.
I don't get that.
Oh, because they had no class.
Yeah.
Oh.
No physical class or no like class manners, things like that.
Whoa.
Yeah, but I'm bummed. Dad joke for the day.
That's hard.
My husband literally walked up to our neighbor and said, "You're like school on Saturday, no class," and walked away. And I'm like, and he was like, and we're laughing. All right. Anybody still writing these down? Okie dokie. Let's take a look back at these guys. So, all right. So this says round to the nearest tenth for each. Now, this is one of those examples of, hey, I have an angle and I have one of the sides. I got to find this side. All right. So I still need to analyze in terms of the angle. So I'm looking at the 57-degree angle. This is my opposite. This is my adjacent. But I have this hypotenuse. So what am I using here in order to solve for x? Am I using sine, cosine, or tangent? Cosine. So I'm going to set this up as the cosine of 57 degrees equals the adjacent x over the hypotenuse 7.1. Now, this is the setup. You cannot just type this straight in. This is an equation, okay? Your best bet is to set it up as a proportion and cross multiply. So I'm going to cross multiply here and I'm going to cross multiply here. This leaves me with x equals 7.1 times the cosine of 57 degrees.
Wait, do we have a homework on this?
Yes. It's just not assigned yet. You're going to be fine. You're going to be fine, I promise. Okay. So this, listen. Shh, guys. Type 7.1 times the cosine of 57 degrees in your calculator and round it to the 10th. What'd you get? 3.9. So x is approximately 3.9. That is it. Once you get the numbers to the one side, it is just a calculator after that.
He's gonna come back. He's like,
Wait, what would you use tangent?
No, that could be opposite or adjacent. It depends on what you're finding. It really does depend on what you're finding. Like you could be given like an opposite side and you need to find the adjacent side. That's tangent. Does that make sense? All right, let's take a look at this next one. Shh. All right, 35 degrees. Listen, guys, come on. I have an opposite here and I have a hypotenuse, which I'm trying to find. What am I using here? Sine, cosine, or tangent? Sine. So this will be the sine of 35 degrees equals the opposite 7 over the hypotenuse x. So this one's going to look a little different than example 3 because now that variable is on the bottom. So we're still going to cross multiply. We still set it the same way. So this is going to be 7 equals x times the sine of 35 degrees. Now, I want you to think about this. Let's say this is just a hypothetical. Let's recall some stuff. If I had something like this, 7 equals 2x, what would I do to both sides to solve for x? Divide by 2, right? So Sine 35 degrees is a number. That's all it is. All right, so we're going to divide both sides by the sine of 35 degrees.
So if it's x cosine 35, divide by cosine 35.
And then you would put the sin of 35.
Sine of 35. You got 12.2? Who said it? That's the answer. Yep.
Look, I got the same thing.
Don't have your calculator, do you, Kira? Oh, you do? Okay. Just checking. Let's take a look at example 5, okay? All right, so it says find x to the nearest hundredth, but you have two angles. Okay, now listen, please listen. It does not matter which angle you choose, but the angle you choose is going to determine whether you use sine, cosine, or tangent. All right, so if I chose this one, I have an adjacent and I have a hypotenuse. That would be cosine. So this will be the cosine of 47 degrees equals the adjacent x over the hypotenuse. And I'm still going to cross multiply. So this is going to be x equals 14 times the cosine of 47 degrees. What do we get? I heard someone say it. What? 9.5. Okay. Just for clarification, if we did this one instead, this would now be an opposite with a hypotenuse. So what would we use for that one? Sine. So if I did the sine of 43 degrees equals x over 14.
Wait, would it be 14 over x? Or
No, it's a sine is opposite over hypotenuse. So this can leave us with x equals 14 times the sine of 43 degrees. Someone tell me, what do you get there? What'd you get? 9.5. Yeah. So again, just pick, take a highlighter and highlight an angle and decide what you're going to do from there, and don't switch after, okay? Because it doesn't matter here which angle you choose, you will get the same answer if you do this correctly, okay? Try it on your own. You have an opposite and an adjacent. Yeah.
I'm a little confused. How do you defer which one's the adjacent one?
Hypotenuse never changes. It's always across from the 90-degree angle. Okay, so the adjacent is always going to be whatever's not opposite. Okay.
Oh, wait, did you guys explain
Sure, just fill out your pass and start it, and keep forgetting to log into that dang thing.
Time to get homework.
There's children. Yes.
Yeah.
No, I don't.
Bro, you said you and Gio were homework yesterday, bro.
Yo, he just.
Who wants to go up and show this one? Okay, thanks, Aiden. Sorry, you're just a hair late.
Yo, the only one I know that's up there is Icon.
Kiro, watch your mouth.
Oh,
in school?
wait, what did I say?
Oh, absolutely not. That's
HE double hockey sticks.
The hockey stick, bro.
You like?
oh
Guys, what's the answer to hockey stick flow?
What's the homework?
Huh?
What's the homework?
That's coming.
Oh,
Yeah, I kind of, for this one, I kind of needed your attention today. That's all I'm saying. Don't worry.
He's gonna be intense.
He's going to be very vocal about it too. Like, oh my God. And he's going to look at me like, I don't know how to do this. And I'm going to be like, did you watch the video?
He's gonna say, "How do you expect me to remember all this?" He's definitely.
Oh, he says that. He says that for everything.
I know.
Everything. Aiden, beautiful job. Okay, those of you watching at home, if you did this correctly, X is about 6.8. All right, so it ends up being, so he did, let's see. What did you do? Okay, yeah. You did the sine, huh?
Oh, yeah.
Yeah, I was going to say, it should be the tangent. Yeah, got to use the tangent here. You have an opposite and an adjacent. I think you put it in your calculator correctly, though. So yeah, it's the tangent of 72 degrees over 1 equals 21 over x, cross multiply, and then in this one you will have division. So it ends up being 21 over the tangent of 72, which gives you 6.8. Nice job. Again, just to recap, degree mode. Dear Lord, please make sure you're in degree mode, okay?
Oh.
If you try any of these using radian mode, you will see exactly what I mean. It does not work. Go ahead. Tell me if you get 6.8 for that. All right, as we explore that, those of you watching at home, have a great day.